Hi everyone, my name is Joan McCann and I'm the founder of the Code Lab, a multi-award winning STEM education provider. We work with schools and communities all over Ireland to make coding fun, accessible and engaging for young learners aged 7 to 17. I am delighted to join you here today to talk about how curiosity and creativity drive the way young people learn to code, and why it's so important that they do learn to code. During this talk, I'm going to give you a summary of my journey in STEM. I will explain why I teach coding to kids. We will look at the benefits of learning to code, the skills gained from coding, and we will look at coding languages that are designed especially for young people to learn coding. We will talk about the importance of getting more girls involved in STEM, and I will talk about the Code Lab's Girls Can Code initiative. I will also show you how I teach coding with the Code Lab video-based coding lessons. So let's begin. Today's young people are growing up surrounded by technology. So they have phones, they have tablets, they have YouTube, they're gaming online, and they're using all kinds of apps online. So they're the most digitally exposed generation we've ever had. But most of their interaction with technology is passive. So what I mean by that is they type, they tap, they swipe, they scroll, but they rarely get the chance to understand how all that technology that they're using is working. So they are merely passive users or consumers of that technology. This is where coding comes in. Coding teaches children how to become active creators of technology and not just consumers of it. It shows them that technology isn't magic. It's made by people just like them. And when they understand how it works, they can start shaping it, imagining with it, and building with it. With curiosity, creativity, and coding skills, young people can become innovators and inventors of technology in the future. And that's vital for us. That's what we need in the world. We need these young people to understand how technology works, especially in the world of AI. Technology already shapes almost every part of a young person's life, from how they learn to how they communicate and to how they play. They benefit from learning with technology every day in school. When they grow up and join the world of work, they will also use technology every day. AI, automation, robotics, and digital tools are becoming part of every industry, not just the tech industry. So young people of today won't just use technology in their future careers, they'll collaborate with it, they'll work with it, and no matter what path they take, whether it's medicine, art, sports, business, science, or tech itself, digital skills will be woven into everything. So unless we teach young people how technologies work, they will grow up depending on it without understanding it. Coding fills this gap. It teaches kids how to explore, experiment, and not be intimidated by technology. Teaching children to code isn't about turning every child or every young person into a software developer. Young people who learn to code learn life skills that will benefit them throughout their lives and in all aspects of their lives, such as problem solving, where they're breaking down big problems into smaller steps, logical thinking, where they're understanding cause and effect, creativity, where they're making games, they're making animations, stories, and digital projects, using their imagination, giving them freedom of speech, and resilience. So, debugging. And debugging is when you're learning that mistakes are part of the process. No one can code something perfect the first time. You'll always make mistakes, and it's a matter of using your problem solving skills and your resilience to figure out how to fix that problem. And confidence, seeing something that you have built come to life, which is huge for young people. So, as you can see, these are life skills. They're not specific to coding, and they're actually skills that are required across all STEM fields. So, by learning to code, children will learn these skills. Coding takes that natural curiosity that kids have and they're urged to ask why and what if, and it channels it into something creative. It lets them design, experiment, imagine, and then actually build what they've imagined. When children and young people learn to code, they stop being passive users of apps and games, and they start understanding the behind the scenes of those apps and games. They realize that they can make things too. And that sense of empowerment is transformative for a young person. These skills stay with them for life. They can use them in all aspects of their life. So whether they choose a career in tech or in something completely different, the mindset that coding builds is universal. I'd like to take a moment now to share a little bit about my own path in STEM because I think it helps to show just how many different directions a career in technology can take, and that it's not all heavy coding or complicated maths. So, as a child, I loved arts and crafts, jigsaws, making things, learning how things work. And in secondary school, I wasn't sure what I wanted to do after school, like a lot of people aren't. And I narrowed it down to computer science and electronic engineering. And in the end, I did computer science. I was an average student at maths and physics in school. I really liked both of them, but I found them very difficult. But I didn't let that put me off. And that's a really important message for anyone who's at this stage of their education journey where you're picking something for college or you're picking a job. Don't let fear stand in your way. Go for it anyway. So off I went to college. I studied in DIT in Kevin Street in Dublin, which is now TU Dublin, for 4 years. And I qualified with a degree in computer science and software engineering. So in college, I learned that software development is as much about thinking, problem solving, and analysing as it is about typing code. So it's not all techie, which suited me very well because I wasn't hugely interested in the techie side. After college, I got a job in IBM and I started out as a software tester and then as a developer. And I was good, but I wasn't amazing at the pure coding side of things. I moved on from development then and I moved into analysis and design, which involved working directly with customers to understand what they needed and to design the solutions for them and then hand those designs over to the coders. So that's where I really found my strengths. I realized that this is something I loved. I loved the communication, the problem solving aspect, the collaboration and working with various different teams. And I got to travel to customers in the States, in Asia, in the UK, and in Europe, which was a fantastic opportunity for me. Then I moved and joined an Irish software company called Phineas, and I started there as a senior analyst. Again, I travelled abroad with their sales teams this time. So this was to customers who were thinking about buying the software but hadn't made up their minds yet. And my role was to go as the technical person and act as the bridge between the technical team and the customer team and to explain what that solution would offer them. I loved this job and I later moved into leadership role within this. And at one point I had a team of 17 people working for me. So you might ask, why did I move into STEM education? Well, I took a career break to focus on my family and have my children. And while I was off, I started volunteering at Coder Dojo and I really loved it. So Coder Dojo is a global network of free volunteer-led clubs for young people to learn coding in a fun, social and creative environment. So if you haven't gone to a Coder Dojo and you think you might be interested in coding, you should look up one near you, pop along, try your hand at coding. You can try out various different languages and you can see if it's something that you'd be interested in. So when I was there, seeing young people so interested in code and seeing how good I was at explaining it, it made me realise that this was something that I wanted to work in. So instead of going back into the software industry, I decided to set up the Code Lab to teach coding, electronics and robotics to the next generation of digital creators who are all the children who are currently aged 7 to 17. And I wanted to create learning experiences that help children enjoy technology, not just consume it. Because I have kids of my own and I could see that technology is fantastic, but there is a tendency in all of us to just watch, to scroll, to tap. and to let the technology do all the work and we just sit there. So I wanted to show kids that there's an awful lot more to technology and an awful lot more that they can get out of it by learning to code with it. If we talk about future careers in STEM just for a moment, I know a lot of people would think that, oh, with AI now, nobody's going to need to work in STEM at all. AI is just going to do everything for us. And I don't think that is the reality. So there is definitely a career path ahead for young people in STEM, even in the age of AI. Their skills will matter. So AI can generate things for us, but human creativity, logic, and problem solving still drive the ideas. So if you take the example of ChatGPT, I'm sure an awful lot of people who are watching this have used ChatGPT for whatever, to help with assignments, to look up things and get some ideas. I've used it myself in my own business to help me with my marketing. So if you use ChatGPT, you type in what you're looking for. So you type in a question and it gives you the answer back. But depending on how you ask it, if you ask it a vague question, you're going to get a vague answer. If you ask it a detailed question, you're going to get a detailed answer. If you ask it very specifically for it's this type of thing, and you're really specific about what you're looking for, then your answer will be far more higher quality than the original one that you had asked. So, in the same way that if we have AI writing code for us, which it's currently doing anyway, so if you have AI is writing code in the future, unless the person who's asking it to write the code is asking it in the right way and is asking it with all of the exact right parameters and the guide rails around it, the code won't do what the person is looking for it to do. And also, the person then needs to be able to check if the code is actually doing what it needs to do. So the skills that are required will still be required by people, but they will just collaborate with AI to build faster, to build better. So that's my take on AI. And I do think there will still be careers for young people in technology and STEM in the future. And the kids who know how to code and understand how technology works at a deeper level will have an advantage over the ones who don't and go into those kind of roles. So understanding code is going to be incredibly important as young people grow up. Now, let's take a quick look at some of the coding tools and apps available for young people to learn coding. So, one of the great things about teaching kids to code today is that the tools are incredibly accessible. I was so impressed when I went to Coder Dojo for the first time to see that there was the text based coding wasn't how they were teaching kids. They were teaching with colourful block based coding where kids created animations and games and took all of the complicated interface away, but still taught all the basic and fundamental coding concepts. So I was really impressed, and I hope you are when I show you these. So you don't need expensive equipment or advanced knowledge to be able to learn to code. You just need curiosity and a laptop or a tablet. You can learn coding from home. You can learn coding in school. Tools like Scratch, MakeCode, Microbit, Thunkable, Turtle Stitch, Lego Spike, and they're just a few. They're all designed specifically for young learners in mind. They use simple, colourful blocks instead of complicated text, so kids can jump straight into creating animations without having to worry about getting the syntax right. And they can create animations, games, stories, art, and even simple apps, all while learning fundamental coding concepts in a fun and engaging way. Let's have a quick look at some of the coding languages designed especially for young people to learn coding. Scratch is a free visual programming language developed by MIT in the US to allow users to create interactive stories, games, and animations by dragging and dropping colorful code blocks. It's designed for beginners and its block-based system makes it easy to learn computational thinking and problem-solving skills. Users can create projects on the online platform, collaborate with others, and explore projects created by the Scratch community. Thunkable is a no-code platform that allows users to build native mobile and web applications through a visual drag-and-drop interface. It is a user-friendly tool for anyone to create functional apps quickly and easily. Users can create apps by dragging and dropping visual components using logic blocks to define functionality, making it accessible for people without coding experience. A microbit is a small programmable computer designed for education to help people learn coding and how hardware works. It has an LED display, two buttons, and various built-in sensors for motion, light, sound, and temperature, allowing it to be used for a wide range of projects from creating games to making a digital watch. You can program a microbit using tools like MakeCode or Python and connect it to other devices via its Edge connector. Microbits are used by millions of young people worldwide to get hands-on with computer science and technology. MakeCode is a free, beginner-friendly online platform from Microsoft for learning to code by creating projects like retro arcade games, programming devices like the microbit, or modding Minecraft. It uses a block-based editor similar to Scratch, but can also switch to text-based languages like JavaScript and Python. MakeCode allows users to build projects in their browser or download them to physical hardware, providing a pathway for users to progress from visual blocks to professional programming languages. So these tools that we've talked about, these tools are fun and powerful, but many teachers feel unsure where to begin with them. So I created step-by-step video lessons that guide students through projects in Scratch and other beginner platforms. So it means that kids get high quality instruction, teachers feel supported, and the teachers can learn coding with their students, which is huge. They don't have to go off and do a whole load of teacher training. They can learn along with their pupils. And most importantly, every child gets to learn coding through school, independent of the background that they come from or the area that they live in. If you're learning it through school, then everybody gets a chance. The most important thing, I think, is that the tools show kids that coding isn't about memorizing commands and it's not rocket science. It demystifies coding and shows them that it's about experimenting, it's about making things, it's about logical thinking, trying things out, finding solutions, realizing something doesn't work, trying to figure it out, and most of all, it's about creativity and curiosity. So if you haven't tried children's coding languages and you're between 7 and 17, or if you're older, you can still try them because they're perfect for adults to learn with. Try out some of these languages. I'd recommend maybe starting with Scratch, but you could try them all, any of them out. There's lots of tutorials if you want to try these at home. I also provide lessons, so you're very welcome to try those and give it a go. You know, it's all about trying something new, and I hope you enjoy it. So now I'd like to touch on something that is very close to my heart, and it's the topic of girls in STEM. So we know that girls often opt out of STEM subjects, not because they lack ability, but because they lack visibility. They possibly lack encouragement or opportunities in STEM. Girls don't see as many role models in STEM as boys do, and these role models are people that they could aspire to follow. They don't see that, and they don't see a path for STEM in STEM for them. So this is the reason why I created Girls Can Code, an initiative from the Code Lab, giving girls a dedicated space to explore technology without pressure, without stereotypes, and just lots of fun. When girls see other girls creating games, they see other girls building robotic projects, they see other girls solving problems and having fun with code, it builds their confidence in their own ability to do the same. And the thing is, when learning environments are inclusive, everyone benefits. So I've seen in my coding camps for younger boys and girls that I would tend to get less girls enrolled on my camps by their parents. But if I run girl only camps, then the girls will come along and then those girls then join the mixed groups because they realize that this is something they love, they realize it's something they enjoy, and they come along. So the mixed group works really well. The girls' groups are specifically to entice and encourage the girls in and show them that coding is something that they actually are going to be interested in. The future of technology will be shaped by the young people in our classrooms today. So the more diverse that group is, the better our future innovations will be. That's just how it is. And when I speak to young girls, and I do say this to boys as well, but girls in particular, about getting involved in shaping technology, I talk about their grandmothers. who maybe didn't work with any type of technology. They possibly stayed at home looking after their families, so they didn't have any exposure to any machinery, any technology of any kind. And so they didn't have any need for it in their daily lives. So that was okay. But things have changed. Girls are half the population and they use tech just as much as boys do. So it's very important, especially in the age of AI, that girls get involved in shaping technology so that it meets their needs and the needs of future generations of girls. This is something I'm very passionate about, as you've probably guessed. And it's something that I would like any girls who are watching this video in the audience to have a good think about that. You know, technology and AI are going to be used in creating all kinds of things, not just tech. So the more women that are involved in shaping AI, in shaping technology, in innovating and creating STEM of any kind, you know, whether it's in STEM healthcare or medical or any kind of STEM at all, it's really important that girls get involved because you're far more involved in the world than women were, even in my generation. So you want the world to work for you. You want when you go to buy something that it works for you as well as it does for guys. So get out there and explore STEM and try it out and see is there a niche or an area in STEM that might interest you and that your skills will suit. So to wrap up, my message is that coding is so much more than a technical skill. It's about curiosity, it's about creativity, problem solving, and the confidence to explore and create with technology. Young people today have incredible potential, not just to use technology, but to shape it for the future. And my message today is simple. To all the young people watching, stay curious, try new things, experiment, don't be afraid of getting things wrong, and don't let fear stand in your way. Every great idea starts with curiosity. So thank you so much for watching, and I hope this inspires you to take your next step into the world of coding and creativity. And if there's anything I can do to help you get on that journey, or if you have any questions, please be sure to get in touch. Thanks very much for watching, and bye bye.